we are going to discuss about customer churn prediction. Okay, so I don't know how many of you guys have the knowledge or have any idea about what is churn. So we'll see some introduction about what all these topics are, and yeah, we can kickstart with the project. I'll be going hands-on, step by step. So the problem here is, or the process here is, I won't be just teaching you guys. I'll be taking the data set. I'll be going through it, okay, step by step, so that you have to understand the process how I am going. So because when I go and did some mistakes means here it's not mistakes. There are a lot of probabilities here happens, right? So you have different methodologies and you have different options. What you are picking, and when I pick something, for example, I'm going for selecting important features. I'm going for feature selection, and I pick only 5 values, and I found that the accuracy drops. Okay, when I get some count, like when the column count or the feature count is around 8, if I found that the accuracy is high, so what is the process I'm going on? Okay, so that is very important, and we'll cover that also, the process how you will be building a machine learning project in this session. So I hope we can go on with the session on customer churn prediction. So talking about the introduction, churn prediction is a common use case in machine learning domain. And if you are not familiar with the term, churn means nothing but leaving the particular company. Okay, so you are just leaving the company. For example, we have companies like cell phone companies, right? Airtel, Jio, and so on, or bank. These companies, what they do is, people used to, they have options, right? So what they used to do is, they'll used to shift between these companies, they'll drop that, and then they'll pick some other SIM cards, okay, get new numbers. So this, for example, they go from one company to other, right? So for that company, it is called as churn, which means persons leave the company. It is important because it's critical for their business, right? So who prefers to lose their customers? Everyone wants their customers to stay with them. So it is very critical for business to have an idea about why and when customers are likely to churn. And having a robust and accurate churn prediction model helps business to take actions to prevent customers from leaving the company. So that's the data science use case of this machine learning domain problem. So when you create an algorithm, that company can now have an algorithm which tells that over a batch of data in this particular month, these percentage of customers are likely to leave your company. So you have to perform something to improve that. So the objective in this session for us is to going to be build a model that can classify the customer is likely to be churn or not. Okay, so we have a particular data set for this, and talking about the data set, we have customer ID, we have credit score of the user, we have country, we have their gender, we have their age, we have their tenure, we have the balance, we have the product number, which means how much product they have availed, we have credit card, whether they are opted or not, whether they are active member or not, what's their estimated salary, and whether they are churn or not. So if one, which means that the customer has left the bank, so this is a bank data set. So once again, bank, anyway, that's a company, right? And if it is 0, which means they have stayed. Okay, that's the whole process of this. So this is the introduction about what we are going to do, and I just wish to go into the actual plan. So first, let us load the data set. So let me go and get this data set which we have. Okay, fine. So let me go with, let us import pandas as PD, import numpy as np, import seaborn as sns, import matplotlib.pyplot as plt. So these are the primary libraries we require, right? So we'll go with that. And yeah, so moving to the next one. So let me load the data set, pd.read_csv. Okay, fine. It seems like we had a telecom company data set. Fine, that is what the example we have seen. So yeah, we can continue with that. We have a data set which is customer churn of telecom company. So I'll go with data.head. Okay, so this is more refined. It's a customer churn data set of a telecom company, like we have seen the SIM card details. We could also have bank also. So here we have a customer ID, we have their gender, we have whether they are a senior citizen or not, whether they have partners or not, whether the customer has dependents, what's their tenure month, okay, the phone service, whether they have opted for or not, whether they have multiple lines or not, whether they opted for internet service, whether they opted for online security and device protection, tech support, streaming TV, streaming movies. So these are all something like the services they have opted. And then what's the contract type, whether it's a month to month contract or a 1 year contract or a 2 year contract. We have whether the payment has been done by paperless method or not, and what's the payment method. And we have the monthly charges, and charges and all will really be an important factor here, I hope so. And the total charges they get. And yeah, if they have anything else, okay, that is also added here in the total charges. And finally we have a churn which is yes or no, so that is very good, so we can encode it and use it later. And the problem here is, I hope you could see there are a lot of categorical features, okay, some continuous features. We have to encode a lot of details. Anyway, we'll do that. And starting first, before starting anything, I wish to go and remove this customer ID from our data, which is not going to be an important factor here. So removing that data.drop, I'll go and remove customer ID. Okay, and you know that the axis is going to be 1, column wise action, the axis is 1, and I'll go with in place equal to true to remove that. Okay, so now let us verify it once again with data.head. Yeah, that is gone. It seems like we have our features and target. Our target is churn. It's a classification problem, and it's going to be a binary classification problem, yes or no question. Fine. So now we'll start with some data exploration. Okay, we'll start with exploratory data analysis. Make it bold. Okay, so we are going to discuss about exploratory data analysis. Starting with, first I'll go with info. We'll do all the visual explorations also here. Okay, it seems like we don't have null values, we have to check it once again, but anyway, we have a lot of object types. This object is nothing but your categorical values. Apart from that, you have integers and float, these are continuous values. It's easy for you to pick if you guys just go with data types. If you just go with data.d types, that is going to give you a precise to one of this. For example, if you just go and use wherever it is equal to object, okay, it will give you a boolean. And if you just go with data, okay, dot d types and just pick that, wherever it is true, you will get that alone. Okay, so if you just go with that dot index, that is going to give you just the column names which is object. So this is how you use pandas. Okay, you have to make it in a way that you get your respective answer. You have to make it, okay, so that's up to you. You have all the options, you have to use it. So this will help me to get, what is this? This is nothing but categorical, right? So this is a categorical columns. I can store it, and I can also take that separate thing and then go with continuous. And what I can simply do is I can just alter this one thing, which should give me continuous value. Wherever the value is not equal to object, it is going to be my continuous. So if I check the continuous, so for that I use different plots, right? So that's why senior citizens, tenure and monthly charge. And once again, the problem here is senior citizen is categorical one only, but encoded one. So that is not a problem here. We'll remove that later. Okay, so this is some way you could use it and then could switch it back. Fine. So you could use remove, I hope so. Dot remove senior citizen. It's a list, right? Anyway. Okay, index object has no attribute remove. Okay, we'll do that later anyway. Fine. So yeah, we'll take these things later. Apart from that, now it's time for exploratory data analysis. So I'll just continue with that. And yeah, so we'll go with data.describe. Okay, like wait guys, I'll just try to do it. It's not that much difficult. Okay, so let us make it as a list. And in list in Python, we know that we could do it with pop or remove. If I pass the 0th index, that is just going to remove that senior citizen. So now if I check continuous, we don't have that. So this is a way you could go and leverage that. For example, if I want to add the senior citizen to categorical, I could go with categorical.append, right? It's a simple basic Python. Since it was an index, it's not a proper list, it was a collection of items. Turn it into a list and then perform what all things you require. Okay, so I could directly pass the senior citizen to add it there, so that I got that there also. Okay, so we'll be having that. Okay, this should also be converted into a list. So the categorical equal to list of categorical dot append that senior citizen. Do it in a single line. Fine, done. Okay, so data dot describe, we have few numerical features only, that's why we don't got the other details. And we have tenure and monthly charges. Fine. And moving into the next one, which is going to be data dot shape, and that shape is nothing but, here we have 7,000 rows and 20 columns. Fine. And I wish to personally explore, before starting with anything, I want to explore the churn. Okay, so the data of churn is going to be our target variable, right? So what do we have there? We have yes and no, yes or no. I'll go with dot value counts. Okay, here we have something, right? This is a problem, guys. Problem here is we have no in nearly 5,000 places, and we have yes in nearly 2,000. Approximately it is around 2,000, right? 1,800. Let us consider it as 2,000. This is called as an imbalance in the data set, and the reason behind this, you should be having somewhat nearly equal. A 40-60% will be really good, but this is not. For example, if I just divide it with data dot shape of 0 and then just multiply this entire thing with 100, that is just giving me percentage. So nearly 73% of your data tells no, and nearly 26% only is giving yes, and this can lead to a bias on towards no. Okay, most customers stays in that company, that's fine, but the problem here is when you train your model, this is an imbalanced data set. The problem here is it is an imbalanced data set because the target should be somewhat nearly balanced. If you have 40-60, that's fine. If you have 45-55 or nearly 50-50, that's really good. When you have like 20 and 80 or 25 and 75, you are actually losing a part. Okay, so most of the yes, when even though the real in real time scenario, if the output is yes, the model may give it as no, and the reason behind is it can be biased towards one side. And there are certain ways to solve it, because if you haven't solved this, some problem arises. I'm going to tell you, I'm just going to leave it as such. I'll train a model, make some predictions, and then we'll come back here and we'll be handling this imbalance, so that we'll see directly how it is impacting our output. Okay, so and particularly in making this balance, we'll be using our sampling technique anyway. So before that, let us go on and make some visualizations, and even before that, I need to just check for duplicate values. Duplicated.sum, 22 duplicates are available, so I'll go with data.drop_duplicates. Okay, I need to pass a parameter. Let me check the param name. I think it is not how anyway. Okay, we'll check their documentation itself. Drop duplicates. If you have doubts, you could check their documentation on particularly keep. So what entry do you want to keep in the duplicates? I want to keep the first entry. Okay, default is first, fine, no issue. So I don't want to mention anything, just in place equal to true will be fine. Okay, that is good. So data.shape now. Okay, fine. So data.isNull.sum, if null values are there, you know how to handle it. Okay, no null values, that's really good. Fine. So now we'll move into some visualizations. So before starting, I'll tell you another feature for you guys. With SNS, you could set a theme. I'll go with set underscore theme. Okay, set theme, and the style I'm going to have here is you can have a dark grid background, you have a white grid and so on. That looks really great. I'll go with I'll tell you guys. So when you go with a normal one, it will be different. Here you could commonly set some features for every graph. It will be in the same format. Okay, so for example, let us go with sns.countplot. Okay, and the data will be data. So here I'll go with y value instead of x. I'll go with y as churn, and what I'm going to do is I'll just change the orientation into H, which is horizontal way. So you will get a graph like this, which is a horizontal bar plot. Okay, this is a count plot, right? Once again, this is nothing but a bar plot. It's a horizontal way. This is what the dark grid is, the background you could see, right? So if you don't have it, it will be white or in different color. Here it looks good. And we have a set one, which means this red and blue, which I prefer the most. I got this. Okay, so this is the count. We can see that there is a huge imbalance. We'll handle it later. Okay, so the imbalance is one of the important thing you have to consider here. Apart from that, I think we can move into the next step, which is, once again, I'll go with head, and let me manually verify. Okay, the categorical we have selected. Okay, we have appended the okay, categorical is not okay. It seems like something happened here in this part. After this, generate it into a list. Here itself, if you just declare it as a list, that will be really good. Fine. So here just categorical dot append is fine, right? Fine. So now if you go and get your categoricals, you will get the details. So gender, partner, and senior citizen, here it's a categorical one, and then dependence is a categorical one. Then we have phone service, really good, fine. Multiple lines, internet service, security, backup, all these things are going to be categorical one. Total charges is not a categorical one. There are some misinterpretations here, so their data type is not proper. Okay, so we don't need that, so we'll just use dot. Okay, I could go with dot remove and enter the particular column, the detail name. So now it has been removed. So in Python we have remove and pop. If you go with pop, you have to mention the index number. If you go with remove, you can mention what type it is. So why am I collecting this, all these things is, I'm just going to use a for loop and then get all the count plot of it. That will be really easy, right? Why you want to go and do it manually? Make use of the programming language wisely. Okay, so we have now, yeah, remaining things are fine. This is a categorical one. Okay, fine. So now what I'm going to do is, for C in categorical, okay, just get their names in C and then go with plt.figure. Every time you run a plot in a for loop, okay, everything will be accumulated in the same thing if you don't go with plt.figure and show. So every time you run a loop, create a new figure so that it can be plotted. So I'll go with 12,6 size and go with sns.countplot. Since it's a categorical one, the data equal to data and x equal to your C. Okay, fine. So we'll set a title with plt.title, and we know that we could use formatting from Python and create a placeholder count of C, which is going to be the column name, and then finally plt.show. And for our confusion, without avoiding any confusion, I'll add some line here, print. Okay, so we'll add some empty lines here for our convenience, so that we get a gap between that. Okay, if you want to reduce the size, you could go with that. For example, if you want something like 6x4, it will be really small. We'll go with 6x8. Let us see how it is. Okay, it's lengthy. X-axis I want to increase. We'll go with the reverse way, 10,4. Okay, this looks fine. So see guys, we need to understand the column. So we have male and female nearly equal. Okay, so it tells that this is not going to be a useful factor here. The gender won't be a deciding factor. and we have a equal count. That's good. We'll see that whether it's having effect or not. We'll see that not here, but we have equal count in gender, we have equal count in partner, yes or no. The dependence we have yes or no is, we could see that their count is drastically less, and phone service availed is yes by most of the people. Multiple lines, if they don't have phone service, that's red. Whether they have yes means it's green, no it's somewhat equal. Internet service, they have opted, okay, fiber optic is preferred by most of the people. Then online security is no by most of the people and yes by very few people. This is their count, and after seeing this I'll be adding a hue, guys. That is going to give you a lot more understanding on the data. See here, online backup yes or no, no is high. We have device protection, no is high. Tech support, no is high. So all these additional stuffs, right, unnecessary things like tech support, device protection, online backup, security, those are not preferred by most people. Okay, and then the count of streaming movies and TVs, that is high. We could see that the month to month contract is really high. 1 year contract is less, 2 year contract is less. Most people prefer for paperless billing nowadays, and the count of payment method is electronic check is most, and the churn count we have already seen. Okay, and the senior citizen is very less. So now what I'm going to do is I'm going to add another feature here. So in this single for loop, I'm just going to pick this, okay, and I'm going to add another one, which is nothing but here add a hue column, and the hue is going to be whether the customer has churned or not, and this is going to give you, we could see there how much people churned from both of these categories, right? So what all categories we have, how much people churned in that, you could get that here, right? So that's actually one of the positive thing here. So what I'm going to do is, let us go with the confirmations that, yeah, so we could see that the male and female, the yes means churn count, we could see that their churn count is nearly equal. So this gender is not going to be a deciding factor because they are almost same, and we have the count of partner, and we could see that if the partner is no, they are most likely to churn. If they have partners, they have less churn count. And the dependence, if they don't have any dependence, they are churning the most. Blue color, if it's high, more churn. Okay, and the phone service, we couldn't see, it's very less. And multiple lines, we have the trend here in the internet service, fiber optic, most people are obtaining it and then they are leaving from the company. And online security, no means they are leaving a lot. And then if they have online backup, no means they are leaving. Okay, so these are all their relationships. You have a lot of categorical one, you could interact and understand. See here, month to month contract, every month if they have contract, so they are leaving the most. If they have 2 year contract, the churn is very less. So what the company could do is they'll try to make their customers to become a 1 year contract or 2 year contract, so that the churn decreases, right? And yeah, the payment method, electronic check, they have the most count and they have churning the most. And this is just the same column, so we get this. And count of senior citizen. So in senior citizen, you could see nearly in senior citizen, 75%, more than 75% of senior citizens are likely to churn. And here the count is less, right? So here they are nearly equal. Half of them are nearly churning out, okay, in the senior citizen. So they have to devise some specific plans for the people to stay. That's up to them, right? So yeah guys, that's it about the categorical features. Okay, and apart from that, if you want to explore the continuous features, we could explore that too. Before that, I hope it's clear till now. So we have started with the basic exploratory analysis, and this is a categorical analysis. You could do furthermore categorical and continuous feature exploratory data analysis. And what I am going to do is, in the continuous, we know that we already got two peoples here, tenure and monthly charges, but that's not enough, as we know that the data.d types. Okay, so we have seen that the total charges is a numerical column, but it has been given as an object. So what I'm going to do is I'm going to turn the data of, we'll change their data type, okay, total charges is equal to data of total charges dot replace. If we have some discrepancies, just replace it with 0 and then just change their type as type. Let us go with float 32. Okay, fine. So now if you go with data.dtypes, you will be having float values. So now if you pick, okay, and apart from that, yeah, we could go with data. We will make it manual continuous equal to continuous dot append. Okay, we want to append the total charges here. Fine. So now we will create some function here, continuous values, right? So first I'll create a function for this KDE plot. Okay, we'll get the feature name, and what I'm particularly going to do here is I'll go with plt.figure with figure size equal to n,4, plt.title. So we'll set some site title here with formatted statement KDE plot. Okay, here I'll pass feature, and apart from that, yeah, we'll set some access details. That will be fine. So the access 0 will be equal to sns.kde plot. So I'm going to give two things. So the data of where the data dot churn is equal to no. Okay, and we'll pick the particular feature alone which we want to get. That particular column where the label is no, I'll give the label as this is the churn is no. Churn no. And similarly, I'll go and pick access 1, which is going to be sns dot. Am I missing a? Yeah, it's fine. KDE plot data of data dot churn is equal to yes. Okay, where the churn is yes, I'll get the particular feature column and then comma the label equal to churn yes. Okay, so finally we'll go with after this. This is good. So I'll call this KDE plot to plot my okay, we'll go with for CO in continuous KDE plot with CO. That is fine, right? We'll get the plot. If everything is fine, this is what the plot we'll get. So in a single plot we are giving two KDE plots and we are getting their color, and what you could see is blue and red. We need to get okay, what is blue and what is red? We need to enable the legend. So go with plt.legend, plt.show also. Okay, now it's fine, right? So no is red and yes is blue. Okay, so this is what the plots we are getting, and any observations which you guys could made, it will be really good if you try to make some observations from this. So we could see that their count, the density, yes and no, when the tenure is less. The can you understand this? This blue color, the density is high here because the churned people are high when the value of tenure is low. When the tenure is high, the people churned is becoming less, and the reason behind it, when the tenure or the month period they have is high, they are likely to stay. No one just pay for the entire thing and then leaves in the start itself, right? If they pay for really 1 or 2 months, what they'll do, they'll just go with that. So that's tenure. And monthly charges, when the charges increases, the churn increases. That's what I could infer here. When the charges are less, the churn is very less here. And then the total charges is completely okay. KDE plot for total charges, we could see the churn is less when the total charges are high. This is somewhat not relevant with the remaining things anyway. So we'll make some more observations with sns.scatter plot. Before winding up, we'll add x equal to, or data equal to data, x equal to monthly charges Okay, and then I'm going to plot y equal to tenure, and hue I'll add it as churn. So this is what I'll get. So yeah, we could see a lot of blue here. When the monthly charges increases, the people churn increases. The same interpretation. So here I could also do the same thing for total charges. I think this could pick something. So this is the trend in total charges. Okay, when the total charges increases, the tenure increases, obviously, because when the tenure is high, then only they pay. Okay, apart from that, we could see a bunch of details, and the total charges is not helping. Okay, we could have a mix. Fine. So that's it about data exploration. I think I could now go into data pre-processing. Okay, so we'll start with data pre-processing now. Enough of exploratory data analysis. A lot of trend we have seen. Finally, before winding up, I could go with data.corr, but here the numerical features are less, right? So after encoding, if you go with that, you could get some more precise details. Okay, and yeah, we'll encode it and then come into heat maps and all. Before that, we'll go with x equal to data.drop. I don't want my target here with my feature. Just go and drop churn column, and the axis is 1, no in place because I need it in y. So data.drop, sorry, data of churn, right? So yeah, we'll take some we'll do some normalization. So from sklearn dot pre-processing, import min max scalar. Okay, so the min max scalar is equal to min max scalar. Just fit it and get it. So we know that the continuous values. Okay, I'll get x of tenure, right, is equal to min max scalar dot fit and transform x of, just give it as a 2D, otherwise we'll get error, tenure. Okay, and then do the same for remaining things too. We have 3 numerical, one total charge, another one is monthly charges. Total charges, I just paste it here. And this is going to be monthly charges. If everything works good, we will be getting the normalized values. Yeah, so fine, we'll check the x now. Once again, x dot head for verifications. Yeah, I've just scaled those values. Fine. So next what I'm going to do is I'm going to go into, just pick my categoricals dot head churn not in index. Okay, so now I'll just remove from categorical dot remove, since we have taken it from the data. Okay, so now we'll go and get x, we'll be getting. Fine, so these are all the categoricals we have. We can handle the senior citizens anyway. So we just need to encode them, and we know that we could do it with from sklearn dot pre-processing import. I'll use label encoder for all these things. Okay, and what I'm going to do is create an object encoder equal to label encoder. We have seen this, utilized it multiple times. So going with for C in, okay, categorical. And now what I'm going to do is I'll first fit encoder dot fit, okay, x of C. So once it is fitted, okay, before transforming, we'll do it in, yeah, I'll go with x of C is equal to encoder dot transform. We'll do it separately, and then x of C, just transform it, and then we need to know who is who, right? So I'll go with a variable which is called as mapping. Since we are doing it for multiple columns, we need to know female is given as 1 or 0 and here partner is given as 1 or 0, we may get confused. So I'll make a dictionary here of what all the features they are doing. Okay, I'll zip it with in encoder. If you just get classes underscore, you will get the different classes. So that will be the features, comma, and encoder dot transform. You could encode it directly dot classes underscore. Okay, so these things you could do. So that will be your key and value pairs there. And finally I'll print, okay, C, and then we could add colon, comma, the mapping one. So just run this. Okay, we got some error. I think I need to take this out. Fine. Okay, this one. Yeah, this is what I am expecting. So the gender 0 as 0, 1 as 1, no as 0, s is 1, dependence. Okay, so in that manner, so it has been. So okay, so here what's the problem is, I'll run this one once again from data. The reason is the program has started running, okay, and then what happens is now it won't be having anyway. So fine. So it has came and got error here. So the male and female has already been encoded. So it has been done once again. So I'll run this once again freshly, so we get their proper details of what is what, which is required when you go and build later on, when you go and build your predictive system. So that in that place it will be really helpful. This is what my x is now. Everything is numerical values. So now I think I could go with x dot correlation. So we'll get a correlation table and do it in a heat map. SNS dot heat map. X dot corr. Okay, so corr we could do, but we don't have the churn column here. So I'll create a temporary one. Temporary equal to pd dot concat, right? So we need to pass two things. A tuple which is going to be x and y, and the axis is going to be 1. Temp, we'll check it whether it's proper or not. Yeah, the respective churn yes or no is available for us. So I could go with temporary.corr, because the reason behind is I want to find how one column is related with my target column, right? So that's the reason. So okay, there's a lot of details we have here, and we also need to encode our thing which we have forgot. Okay, so the y value you have, right? So you have to encode it anyway. So the y equal to encoder dot fit and transform y. So now we just make a temporary one. What happened? Okay, this is not a series. Fine. So it will be a numerical one. Anyway, we'll go with p. Yeah, check y. Yeah, it's an array. So y equal to y dot pd dot series of y. That will do the task. Now concat, fine. Now take it here, you will get completely numerical. Okay, so now we got a lot of null values too. Okay, it seems like what we have tried to do is creating a lot of problems. I think it's fine. We'll just leave this correlation for now, and runtime we'll take it from data. Our data is not corrupted. We are doing it in x and y. Okay, so if your data is corrupted, you have to take it from there itself. Now we have the categorical list without churn. We'll take that, encode these things, get x. Okay, no null values, x dot corr. Fine, so we'll go with y, transform it, length of y, just checking whether they both have same shape, 7021, 7021. Fine. So now we have our x and y. So apart from these, we'll just go into the next step, which is going to be, yeah, so the pre-processing basics has been done. We don't have null values too. So what we could do is we could go, and the problem here is we have a lot of categorical values. Okay, So talking about the continuous values, if you want to check for outliers, we have only 2-3 columns which is outliers, which is continuous one. You could perform outlier detection too. So first I'll go anyway with from sklearn.model selection, import train test split, okay, and go with xtrain, xtest, ytrain and ytest is equal to train test split, and I'll go with x value, y value, test size equal to 0.2 and random state I'll go with 42. Okay, so picking this, fine. So check it once again for the shape so that they are not they don't have any mistakes. X test, the test and train shape should be y train, right? So the respective thing, if it's proper, then which means no issue. And we have 19 features. Okay, 19 features is huge anyway. So before going into that, I just want to start with the modeling. Don't go for feature selection at the start itself. We could go and start with from sklearn.tree import decision tree classifier. So the model 1 equal to decision tree classifier, and yeah, here we could go with model 1.fit, directly fit my xtrain and ytrain. So I'm not directly jumping into here. I'm just trying to make some results and see how it works, and then come back, and we need to change a lot of process. We need to go for feature selection. We need to handle the imbalance. We'll do that. So I want to predict the x test, and we need to also import from sklearn.metrics import accuracy score, confusion matrix, classification report. Yeah, so the training has been done, prediction has been made, so the score equal to score 1. Okay, accuracy score, I'll pass my weight test and original answer and the predicted one, right? So the score 1 multiplied by 100 is going to be the model performance percentage, which is around 73% we got. Okay, so yeah, like that I could do for another algorithm before verifying with any other metrics. Okay, we need to import it. So from sklearn.ensemble import random forest, okay, classifier, and pick it as model 2, model 2.fit answer 2. Change the model name, which is going to be, instead of decision tree, just random forest classifier, and we'll make some score for score 2. We'll see how this works at the base thing. Okay, this should be 2, so we'll be getting some answers, which is 78%, really good. So we'll try to make some process here. So the problem here is we have a lot of features. Okay, we need to pick the important ones. So yeah, after xtrain and xtest, I'll implement another thing. So from sklearn.feature_selection, I'm going to import select k-best. Okay, so after selecting k-best, I also need to take my this is a classification problem. What metrics can we use? We could have, think about the metrics we have. We have C2 test, f_classif test, or mutual info classifier. Anything can be taken. I'll go with f_classif. Okay, so here the k-best is equal to select k-best, and I'll pick f_classif as my metric here, and the number of value, the k value is going to be integer, which is, I'll go and pick the best 10. Okay, and mentioning this k-best.fit xtrain and ytrain values. Okay, so xtrain dot columns of, okay, I'm going to get kbest dot get underscore support, and that will give me the best columns, the best 10, right? So let us pick this as xtrain selected, okay, is equal to, this is just column names, pick the entire data, that is, use this as a filter, xtrain selected. Also when we go for testing, we need the xtest selected, so that is, instead of train we need to pass tests here. Fine. So yeah, so now what we need to do is, instead of all these places, instead of xtrain, let us pass this selected features and test how it alters the prediction. This is 73%. Okay, so no, not much, that much improvement. If you go and select the features, maybe if you go with here we'll be going to get error. We'll sort it down now. Maybe when we go precisely with a selected number of, okay, for white test we don't have any selected and all, it's 79. Can you see the improvement here in the algorithm? From 78 it moves into 79. So apart from these, you have to manually check how much number of feature or what important features does, okay, or else I'll suggest you to go with the correlation and find which are all really has some features which is having some slight good correlation. See here, 74 occurs of dimensionality, this now reduced to 77, maybe its performance, so we'll have it as 10 for now. Okay, so that was performed well in our random forest algorithm. We are going for ensemble based one, and the reason behind is we have a lot of categorical features. Tree based algorithm may work good compared with other algorithms. So we got around 79% here. So if you want, you could go with some other algorithms. I'll limit with these two. XGBoost algorithm, logistic regression. It's a classification problem, right? Anyway, cat boost algorithms can be used. So yeah, apart from these, now the problem arises when I go and check the confusion matrix of both of these scenario. For example, let us go with the confusion matrix. We have imported it already. So the task is pass your white test and answer 1. Okay, confusion matrix, right? So I'll take it in you will get a plot sns.heatmap. Okay, we need to pass cm, annotation as true, and format, I'll go with a new format which is g. Okay, just the whole number. So you get, for example, you can see that the 0 correctly predicted as 0 in 856 places, 0 wrongly predicted as 1 in 179 places, and 1 correctly predicted as 1 in 173 places, and 1 wrongly predicted as 0 in 197 places. This is the problem, guys. See here, since the majority or the balance is towards, we have seen an imbalance starting, right? It is towards 0. We could see that it is performing towards 0 only. So a lot of 1 has been misinterpreted here. Even though the overall accuracy is 73%, we could see that nearly it fails. When you go and check with classification report, you will get the true answer for this. Okay, you want to check that too, because you can't make a generalized model with this, because whatever you giving, it is giving as 0. They are not churn. What's the point of it, right? So we need to get a classification report and get some nice results from this. Okay, when you go for a classification report, just print it. Okay, I used to forget this. When you print it, you will get a report which is the precision. Okay, how precise it is. Towards 0 it is good, but towards 1 it's nearly half. That is very, very poor performance. So you could also check with your good performing algorithm, which is your random forest. So instead of this, go with test 2. This is cm2. Just plot the cm2. And here we could see that this is performing towards 1 little bit better compared with the previous algorithm. Am I correct? And the reason behind is it is predicting more towards 1 and 0 towards less. That's good. we should check the classification report too. Okay, so we'll go with answer 2. Okay, 0.60 improvement, that is really good, but you can't just make up with your selecting the columns and go with this will be a really problem. And the reason behind this, the only problem you have is nothing but SNS.count plot, data equal to data, x equal to churn. Okay, so the problem you are obtaining is this, because there is an imbalance in the target. So to solve this or to handle this imbalance, what is suggested to do is you have to either go for undersampling or oversampling, and we have already seen what is sampling. Okay, so in sampling we have some techniques, right? So you can pick some samples. For example, in yes we have nearly 2000. Okay, so in no, if I just pick randomly 2000, so this becomes equal, they both are now equal 50%, so the algorithm won't be biased towards one side. That can be done. So there are packages for doing it, it's simple. Or else you could also go for oversampling. So what is this oversampling is? Just lifting the s towards 5000. We are going to generate, okay, all the features and their respective target are manually generated based on algorithm based on like similar data. So if you have s, what is their feature, some similar data based on algorithm will be created. So you totally you will be having 5000 no and 5000 yes will be available. So I prefer to go with oversampling in this task. So to get that, you can go from imb learn. Okay, it's a library, you can install it. You can go for oversampling or undersampling. Undersampling means getting part of it, oversampling means generating a lot. So I'll go with oversampling. Okay, in oversampling you can import random oversampler. Okay, and the format here is, okay, I'll take it from my x and y. So x comma y. Okay, before that, random oversampler is equal to random oversampler. I'll go with the strategy can be auto, that is fine. The random state, if you want to pick the same guys every time, you could go with random state. And x comma y equal to, I'll go with x1 y1. Okay, don't alter your base x and y. ROS dot fit and resample is the option you have to pick. You can pass your x and y value. Okay, so now we have done it, which means if you go with x1 dot shape, so total from 7000 we are now getting 10,000 because it's generated data. With y1, if you check, I think initially it will be array. If you just turn it into pd dot series of y1 and then go with y1 dot value counts, you will get a equal 1 and 0, which is nothing but now the churn has been trying to balance. Am I correct? Okay, they are nearly equal because the one has been generated data is now available. Sometimes it cannot be reliable because it's a generated data. Sometimes you could go with undersampling. The problem with undersampling is you lose nearly 2500 rows, which are really important, which can be a deciding factor too. Here it's a generated synthetic data which is available. Both can be tried. I'll go with oversampling for this task. So now I have my x1 and y1. So why waiting for? I should just pick this. Okay, once again. So I'm not going to write it once again. I'll just use it here. So instead of that, I'll pass x1 and y1 here. Okay, I think I could just copy these details and go with that once again. Just select the columns. And we could also perform hyperparameter optimization if you guys remember. We'll just select these things. Yeah, so I'll just copy cells and paste it here so that the flow will be correct. Okay, so starting from now we have our x train and y train or new values. So if I fit it and get the best 10 features, it will be different. Selected will be different, the shape will be different now. Okay, and train it and gets result 86%. Okay, you could see the drastic increase now. So let us get the confusion matrix. Okay, 1 correctly predicted as 1. Okay, which is around 981 places. Wrongly predicted is reduced. Let us get the report and get how 1 is performing well. 1 is performing really well. Okay, now since we have balanced it, you could watch it your own eyes that the model is not biased towards that side. Still there are some discrepancies which you could solve anyway. We'll try with random forest classifier and get the score 88%. So this is improving furthermore good since it's a multiple tree, and I could get the confusion matrix really good. We'll get the precision report here for 184%, really good. Okay, so now I prefer that I pick random forest. So once I have done that, still this is not ended. Okay, for random forest classifier, let me just go with I could go and get the from sklearn hyperparameter optimization using randomized search CV. Okay, dot model selection will import randomized search CV. Okay, and let me have a parameter grid is equal to a dictionary which is having the n estimators. So I'll go with setting the estimators as 100, 200, 300, 400. You could check the documentation for these things. The details I'm entering, comma, max depth. Okay, so we'll set it as none. 10, 20, 30, 40. Okay, comma, minimum samples split. It is going to be 2, 5, 10. If you want, you could add, you could check the range and then go wisely. Minimum samples leaf is going to be, I'll set it as 1, 2 and 4, comma, bootstrap. So these are the hyperparameters. I'm getting it from the documentation. You could check the documentation too. False. So these are the parameters I am having. So apart from that, what I'm going to do is first create a model once again. Random forest classifier. Okay, so R of random is equal to, I'll get the randomized search CV. Randomized search CV, and in that the estimator is equal to RF, that's the algorithm, and the parameter distribution is going to be the parameter param grid, comma, and the iteration, let us set it to iterations. You could set your numbers. Cross validation, I'll set it to 3, and verbose, the detail we get is 2, and the random state, I hope that's it, equal to 42. So I'll pick this. Okay, and the jobs, I'll set that to n underscore jobs equal to -1. Fine. So that's it about this. So we could go into the next line now. And yeah, talking about here, we could add yeah, I think we could directly fit it with rf underscore random dot fit. We could pass our x train selected, comma, y train, and then we could go with print alpha print. Yeah, okay, that is not required. First we'll fit it and then we'll get the results later on about which model performed good. Param distributions it is. Yeah, fitting 3 folds for each 10 candidates, totally 30. So you could increase the n iteration and the features so that the fit increases, though it tries to find some best parameters. Maybe without parameter itself, maybe this 88% can be good. Maybe after that we'll get some more good parameters. So that's, we have to check manually. So we should wait for this to wind up so that we can verify it manually. It will be done soon because it's very simple. Only 30 fits is happening. So once it is done, what I'll be doing is I'll be directly going and getting the best algorithm. So you could take it directly with the help of the best estimator. Okay, and you could call it to predict, and that helps you to give the answer. So we'll wait for this to complete. So now that has been completed very soon. Okay, so you could get your best fit using RF random. Just get me the best parameters. So if you get the best parameters, it tell you among these this is the best parameter it has found. And if you go with the best estimator, okay, so you get a model. So you could go with dot predict. I'll pass my X test selected. Is it making predictions? Yeah, so we'll go with answer 3, and we could get the same details like we did here. I'll pick all these 3 plots, and this will give you a conclusion, okay, of whether it is improving or not. If it's not have any significant impact, I suggest you to not prefer this hyperparameter optimization based on each space. Yeah, it's giving you some improvement of 89.5, and if you have some vast apart from these, maybe some different combinations can be found. Anyway, this is randomized search. You could also go with grid search, which takes some more time. That's it. Okay, so now I'm going to use this cm3 is equal to this. Okay, this is cm3, plot that. Okay, so a lot more improvement. We'll see the report anyway. We need to make it towards 1 and 0.84. That's the ultimate best we got. Now it's around 0.86. So you could furthermore tune so that it performs really good. Okay, so now we can also make a predictive system for this company since we are learning for data science. What I'm going to do is, as we know that we have a lot of encoded feature, I'll take this. Okay, so we'll keep this dictionary for our purpose. We'll keep it and we'll make a predictive system. Okay, it will be error anyway. I'll just make it as a comment, a multi-line comment. Okay, no issues, fine. Just have it. So we are going to make a predictive system. Okay, so first, before going into that, we need to pick the important details we require. So the features we need to find, and to get that, I think I could go with xtrain selected. Do it have that column names? Yeah, dot columns. Okay, so this is all the features we require. 10 features from the user. So for x in or for a in, xtrain selected dot columns. Okay, get one by one. So what I'm going to do is, before that I also need to create a registry for this. So input equal to a list, and here whatever the user enters one by one, okay, I'll get it as f equal to integer input get from the user, okay, enter a. So one by one it will be obtained from the user, and that inputs now are append in input dot append the f. Okay, so now enter dependents. How many dependents? Either 0 or 1. So if you want to find what it is, you can check it here, zeros and ones. Okay, 0 tenure. I'll go and enter some random details here, guys. So you can, for example, if the company wants to check for the user, they could go with this and enter the detail of that particular customer. They could also make batch prediction. So like I did with X test, they can get the entire prediction or make this is for one person. Okay, monthly charges, I'll go with 133, total charges 133. Okay, so now all these input of this user, particular user is now in input. So you have the features, so you could make prediction with this. Simply what you could do is, you have to first import numpy snp and then go with input array equal to turn it into an numpy array as array, pass this input, and then once you've done that, you could go with input array is equal to, you have to reshape it because we have trained our model with multiple rows and columns, but now we are giving only one row. Okay, so what I'm going to do is, I'm going to reshape it as 1 comma minus 1, which tells that one row and all the columns. Minus 1 means all the columns. So the answer or result is equal to you ask your best model to make prediction, so that will be really good. And my best model is my rf random dot best estimator dot predict. I'll pick this guy and I'll just go with passing the value, which is going to be I array. Okay, input array, make prediction, print result from model, print the result, and then if result of 0 is equal to 0, then the answer is print chances of churn is no. Okay, else if it's 1, which means print chances of churn is yes, right? Fine, so we'll run this. This particular person detail tells that the chances of churn is no. If you enter some other details and run this, you could make it as a single thing here. So this, if you run this, it will get the input, it will make you the prediction. Dependence, tenure, I don't know what will give you the feature exactly. We'll just go with these things. Here the chances is no, but we know that the model is not biased towards one side, so it will make prediction sometimes if it's s, if it's 1, so the answer will be yes. So this is what a predictive system is, and we have successfully completed this entire thing. Okay, so we have planned for creating a model for this objective and we have completed it successfully. So in the next session, this is a classification, binary classification project, and we have started actually from importing the data, doing exploratory data analysis, making the pre-processing, doing some zigzag things on feature selection, model selection, oversampling and hyperparameter optimization, and finally we have done the predictive system. So that's it. Thank you for watching. So we'll see you in next session. Thank you.